Okay, a trusses is an arrangement of bar of or member connection at joint. In many cases, such as roof trusses and lattice girders, it's assumed that for design purpose, not significant and moment generate at the connection. The connection are often assumed to be nominalized pin. Then, truss can be fabricated from various steel sections available or and joined by welding or bolting. Usually we will use welding and bolting. Two types of trusses. There are only two types of trusses, planar truss and split truss. A frame which has it all member in one plane is called a plane frame, while a three-dimension frame is called a space frame. For the analysis of trusses, they have two force, primary force and secondary force. For the primary force in all members are calculated by applying load at the nodes and assuming the truss is pin jointed and statically determinate. Then the axial force in members may be of tension or compression. For the secondary stresses, consider for heavy trusses like industry building and bridge. They can caused by loading applied between the nodes of the truss, eccentricity or add connection, rigid jointed and deflection of trusses. On the calculating the tension member design, they have a few steps to be determined. First, we need to determine the design axial load (NED). Second, we need to choose a suitable section for the loading this word. And third, find Fy and Fu from the product standard at table 3.1 to get the gross area A and the net area at A nets. 5. Substitute the value into the equation to work out MPLRD and NURD. They have formula to get the another formulas. For Angus connection by a single row of bolt, use the required equipment to work out NURD from BSEN 1993-1-8, which will depend on the numbers of bolts. In this project, we'll be using two bolts for the tension and compressions. The design tensile resistance is the lesser of the value of MPLRD and NURD. For 6, we need to carry out the tension check from the formula NTED over NTRD should be less than or equal 1.0. This is my a few calculation started after a prelim. From prelim we can determine the trusses loading and the trusses are suitable size on choosing the suitable material and grade. For this trusses we'll be using grade S275, a standard grade. First, we need to search for design top chord and bottom chord. Then, we need to find the tension and compression in the trusses.
Greeting, Assalamualaikum and greeting to Dr. Hilton. I'm Ashraf Azmilan, CF101111. So in this project, I basically designed a beam. Okay, so for the length of my beam is 5.6 meter with width of 3.3 meter. So this is the action of the beam, and the permanent action for the beam is 3.7 kN per meter square, and the QK variable action is 3.3. 3.3 3.3 3.3 kN per meter. For my design action, kN per meter square. So this FD. FD is where design value multiplied by the width of the beam. So I will get 32.84 kN per meter square. Okay. So basically I use this size of my beam. So 610 multiply 178 multiply by 82. Okay, for my Fy is 275 Newton per millimeter square. So based on universal beam design, by this design I will get H this value, H HW this value I get. So for the classification of cross section, here I use class 1. For class 1, this is the value of class 1. See, 9 EM get 5.57, 71.5. Okay, and then this is flash. This is the limiting value for class 1. Get 66.24. Okay, basically my design is for the size is okay, it's acceptable, and I use that size for my beam. So that's all. Thank you.
Hello, my name is Muhammad Alfi bin Nuran. Today I would like to explain about column C1. For column C1, length of column is equal to 5000 mm. The table 3.1 assumes size 356 times 368 times 129, and for steel grade is 275 and Fy equal to 275 Newton millimeter per cube. For cross-section classification, clause 5.5.2 equal to 0.92. For outstanding of compression flank, refer to table 5.2 sheet 2 equal to 10.22 less than 14. Table 5.2 sheet 1 for web internal compression part 30.33 less than 42. So the section is not last for. For nominal moment, eccentricity EY equal to 277.8 mm and 105.2 mm. For flexure buckling resistance, critical length equal to 5000 mm. For non-dimensional slenderness, lambda 1 equal to 86.39. Buckling about axis YY equal to curve B. Buckling about axis ZZ equal to curve C. Reduction vector x2 equal to 0.78. For lateral torsional buckling resistance moment, conservatively the slenderness for lateral buckling may be determined as equal to 0.55. For roll systematic, one section with H over B less than equal to 2. Use buckling curve B. For buckling curve B, refer at table 6.3. The XLT equal to 0.94, and for MB or D equal to 641.08 kN per meter. Combined loading and axial compression buckling instead of equation 6.61 and 6.62, the simplified expression given below is used. So the answer is 0.24 less than 1.0. That is okay. Therefore, 356 times 368 times 129 is adequate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakir alias my metric number CF180133. I will continue explain about connection. First one, connection truss to column. Second, connection between member. Okay, for the first one, this is the classification we use for the size column. Steel grade S275. VED get from Stanford. Okay, for the board detail, almost the detail we got from the table from EC3. Okay, for the AS, we use 245 for 22 diameter, 20 diameter, DO 22, FYB, we use 8 board size 8.8, FYB 640, FUB 800, and T10. This is the limited spacing of the bolt. We propose for E1 75, E2 50, P1 105, P2 100. Okay. For the shear resistance, we get larger than FVED, smaller than FVRD. Okay, for verify failure, for this we get for FU we use 410 because the T is smaller and the VED smaller than VBRD. Okay, after that, this is the detailing for the proposed size and the spacing. Okay, for the second one, connection between member. First, design shear strength of weld. We get 2 to 3 Newton meter square and millimeter square. This is the formula that we use. For the second one, design the resistance weld per unit length. We get 1.56 kilonewton per millimeter. Number 3, total resistance. First, minimal length requirement. We get 10.13 millimeter. The total required length 80 millimeter. Total resistance 1 to 4.8 millimeter. And then from the formula, we got FVED smaller than FWRD. Okay, for the number 4, weld arrangement. First length, we use 50 after calculation. Second length, 40 after calculation. This is the detailing for the welding length. Thank you.